Hey guys, welcome back to math class. Today we're looking at angle-angle similarity and we're going to talk about some triangles. So I've drawn two triangles, pretend they look similar, and I've told you that they're two angles. Take a second, write that down. All right, so we've got triangle XYZ that has an angle of 32 and an angle of 84, and we have this unknown angle right there. Over here, we have angle PQR with an angle of 64 and an angle of 32, with this missing angle right there. The task today is to decide, do these three angles equal the same as these three angles? And all you know currently is that there's a 32 here and there's a 32 here. So to figure this out, we're going to add the two things that we don't, or that we do know, find that missing one, add the two things that we don't know over here, or that we do know over here, find the missing one, see if they are equal. It's pretty much it today. So my big question is, are the angles congruent? Congruent, which means equal. Congruent means equal. So over here, with triangle XYZ, I've got 32, 84, and blank. So I've got 32 plus 84, which is 116. And then how many degrees are in a triangle? 180. So how much more do I need here? So I'll do 180 minus 116. So 64. So this missing angle here, angle Z, is 64 degrees. Now let's look over here. We really only have to do this once because now we know if this one is 64, this one is 64, this is 32, that's 32. So the third angle over here, how much is angle Q? Angle Q has to be 84 because if there's 180 degrees in a triangle, we know that these three numbers add up to 180. We have two of the same numbers already. So the third angle has to be the same. And that's basically how angle-angle similarity works. All you need is two over here and two over there to figure out if the third one makes them the same. Now let's look at more triangles. When you have triangles embedded inside of each other. So we've got this one triangle and we're going to cut it in half a little bit. Not really half, but I'm going to draw a line right there. And a lot of times it's really easy to say, oh, trapezoid and triangle. So my suggestion is always to redraw when you see these shapes because you have one large triangle on the outside and then you have a smaller triangle embedded on the inside. And the measurements here are 35, x 40.5 gets me from here to here, and then 54 gets me from there to there. So when I redraw it, I'm going to draw the large triangle first. No rhyme or reason why, I just am. This is 35. How much is the bottom? 94.5. Because from here all the way across is 94.5. Now for the littler triangle, we don't know this, that's my x. How much is the bottom? 54. Because it's right there. Now when I find the missing measure, I set up the proportion. I'm going to find a pattern, set up a proportion, cross multiply, divide, unless there's a relationship that you see happening. So I'm going to circle my variable, circle its corresponding side, and then I'm going to box this one because I know some of you guys only have a pencil. So I box 54 and box its corresponding side. Now when I set up my proportion, I am going to do, let me scooch this down. I'm going to do 35 over 94.5 equals x over 54. There's many ways you could set it up. That's just how it looks to me. So you're going to cross multiply here. 35 times 54, 1,890, and then divided by 94.5. I already know the answer, so write this down. Work it out. It comes out to 20 even. So the missing side here is 20. All right. All you have to be able to do really for the new stuff is adding and subtracting and thinking critically a little bit. So good luck. I will see you guys next time. Later.